when you were in elementary school, we learned that in order to effectively add fractions, you had to have the same denominator. So numerator is the top item, denominator is the bottom item. So if I wanted to add 1/6 to 1/4, the answer is not 2/10, right? No way. That's not true. You don't add the numerators and add the denominators and correct and come up with this, okay? That's wrong. You must come up with a common denominator. Between 6 and 4, what would that be, 12?
Yep.
Okay. And if I had to convert 6 to 12, I would multiply it by 2, correct?
Yep.
So whatever I do to the bottom, I must also do to the top, making the top 2. Or the next item, 4 to 12, I multiplied it by a 3. Okay? So your new fraction is here, your new fraction is here, because you have to change to a common denominator. The end of this would be 5/12. Right? That's easy. That's elementary school stuff. But what if you start mixing together letters? Take a look at example 1 with me really quick. Example 1A. 3c plus 3c over 16 added to 5c over 16. You guys see that? Are the denominators the same in A? Yeah. What is the denominator, by the way? Can I just add the way it sits then? Yep. You combine your 3c with your 5c, which will give you 8c. The denominator does not add together, and you get 16. You can still reduce this, folks. The 8 and the 16 reduce rather nicely, don't they? The 8 becomes a 1, and the 16 becomes a 2. Okay? Do you guys see how I tracked this? I need everybody to see this. Stop me right now if you don't see how I got from A to B to C. Okay. You okay over there? All right. Because you're snoring. Letter B. B is a little bit more difficult, folks. 5x minus 4 over 10 minus 3x minus 8 over. Yep. Awesome. All right. The difference of 5x plus 4 over 10 and 3x minus 8 over 10. So, when you look at this, you have to recognize that I am subtracting all of this from that. My denominator is not going to change, right? Adding and subtracting, your denominator doesn't change. All right? So you need to look at this. I'm going to kind of write it out a little bit differently. 5x plus 4 minus 3x minus 8. You guys see how I just rewrote it? I just wanted to give myself a little more room here. You see that negative symbol? That subtraction symbol, that negative symbol, causes the 3x to become negative and the 8 to become a positive. Now I can look at this entire thing having distributed the negative over the 3x and over the 8, and I could combine all of these terms. Okay, you don't have to separate it and do it this way. If you can follow it in your own head, that's fine. But 5x and a negative 3x is how many x? Good. A positive 4 and a positive 8? Now you're looking at this going, well, what else can I do? I don't know how to reduce this from here. Well, 2 can be factored out. It looks like that, right? Do you guys see how I factored out the 2? Can the 2 and the 10 reduce? Becomes 1/5, doesn't it? So the numerator is x plus 6. You don't necessarily have to write that 1. If you want to, it's fine. Over 5. Okay? X plus 6 over 5. We've got another one just like it in example 2. They do just a couple more. 3 over x plus 4 added to, oops, let's try that again, x plus 4 added to 1 over x plus 4 is equal to 4 over x plus 4. Can I do anything? Can I reduce the 4 with this 4, Connor?
No.
Correct. Good job. Yep. This can only reduce if this entire thing is reducible by 4. That's why over here we had to factor out that 2. That 2 then is reducible with the 10 because the factors reduce one another. The factor 4 does not reduce the factor x plus 4. Very good. B. Now let's go to the next page real quick. Okay, this is letter B. You're looking at this saying, well, the x minus 3 and the 3 minus x are similar, but slightly different. Well, yes, they are. So in order to convert one of these to, so that they match, all you need to make is that x has to become a negative, and that negative has to become a positive. In other words, if you flip the signs of both of these, it will match with that. All right? In order to flip the signs of both of these, we simply multiply it by a negative 1. Okay? We multiply it by a negative 1. Okay? And by doing that, you end up with, the first thing doesn't change. Okay? So far, so good. This is a little bit weird, but bear with me. This causes that to become a negative. Okay? The negative symbol that we factored in causes the operation to become a negative. So the denominators are the same. What will the numerator be? -5. Bravo. Okay, this is the normal way of writing it. You just kind of float it out in space. Example 3. Here's where it gets tricky, and actually Gabe and I were just chit-chatting about this a second ago. The last lesson you guys did involved common denominators. And in order to do that, what I had you guys doing was prime factoring and discovering what they had in common. This one's not too hard to identify though, is it? Can you guys see what the common denominator would be here? If not, let's factor it. Running out of room. So this is 2 squared, and this is 2 times 3 times 3. So you take the largest power of any factor present. So what is the largest power of 2? Is it 2 or 2 to the first?
2 squared.
2 squared, good. And 3's, what's the largest power of 3's?
3 squared.
So it's 4 times 9. What's the denominator going to be? 36, 36. Okay? In order to convert 4 to 36, I had to multiply it by what? 9. That means I need to do the same on the top. So my new numerator is 9a. Okay? What did I do to the bottom to make it a 36?
You multiply
by 2. Okay. Multiply it by 2. Okay? So you now have 10 plus 24a. Okay? They have it broken up a little bit differently, but it's the same idea. This negative acts upon both of these items. It looks like this. 9a minus 10 plus 24a. All of that is going to be over 36, right? Because the result is going to be that denominator. Okay? If you look in the book, that's actually how they show it. The negative over the 10 causes that to be a negative 10. The negative over the positive 24 causes that to be a negative 24. Okay, you see how we're building this? You can't miss out on this negative. If you don't distribute that negative over both pieces, because you're subtracting both pieces from that 9a. If you don't distribute that negative over both pieces, you won't have the right answer. So you should end up with 9a and a negative 24a. What is that, a negative 15a? All of that over 36. You might look to see if you can reduce it. Well, if you pull out a negative 5a, 3a plus 2 over 36, you still can't reduce the 5 with the 36. Okay, and that's what the book shows. They show you this answer, but they also show you if you try to factor to see if something here will reduce with that here, it won't. That ends up being your final answer. Okay? That's the end there. Same process over and over. Example 4. What if you are asked, my friends, to find the perimeter of the rectangle shown? Don't worry about the fact that it's weird looking variable business. You still know that perimeter is 2 of the lengths added to 2 of the widths, right? Perimeter is the sum of the sides. So A12, A12, A minus 1, 4, A minus 1, 4. You're going to add all that together. Rather than adding it up that way, though, it's easier if you actually do 2 of the lengths. So 2 A minus 1 over 4s, 2 of the lengths, added to 2 of the widths. Okay, so these are the lengths. I'm just calling them the lengths. These are the widths. The sum of that will give you your perimeter. You guys with me so far? How are you guys over here? All right. This is literally 2 over 1. Okay? So 2 times A minus 1 over 4 becomes 2 times A minus 1 over 4. I'm leaving it like that because I'm going to reduce it before I add it together. Just easier. And that's how they did it. That becomes a 1, that becomes a 2. Okay, 2/4 is 1/2. Added to 2 times A over 12. I'm leaving it that way. 1 times 12 is 12 because I'm going to reduce it. 2 becomes a 1, 12 becomes a 6. And I reduced it prior to adding them together because it's easier to find common denominators of smaller numbers. Okay, it's just easier. Common denominator of 6 and 2? 6. To make 2 become a 6, what did I have to do? Multiply by 3. Good job. So 3 times A minus 1 is 3. a minus 1. I'm going to leave it like that for now. Okay. Do I have to do anything with this guy here? A over 6? Nope. A over 6. All right. Well, I might as well distribute that because in order to add 3a minus 1 to a, I need to have 3a minus 3. Okay? 3a minus 3 plus a, all of that will be over 6. You end up with 4a minus 3, right? And you might look at this and say, boy, that 4 and that 6 will reduce nicely. 4 is a 2, 6 is a 3. Nope. 4a minus 3 is a complete unit. It is a complete factor. Only way you could reduce it with the 6 is if something could come out of both of these pieces that was reducible by the 6 that's by itself. These are like the ones me and Gabe were just doing a couple of minutes ago. Next page, example 5. What you guys did in the previous lesson was a precursor to this. 3 over 2x minus 1 over 8x squared. Greatest common factor of 2 and 8? Anybody know?
8.
8, bravo. X and XX? X squared. You always take the largest power of the denominator of the variables present. Okay? To convert 2 to 8, I have to multiply it by a what? 4. To convert x to x squared, I have to multiply it by? On the top, I now have 12x. Good? Nothing to do here, would you agree? Okay. So the result is going to be 12x minus 1 over 8x squared. You can't do anything with the 12x and the negative 1. You can't combine them together. They're not the same type. 12x is a variable. Negative 1 is a constant. There's your end result. There's your end result. The trickiest one in this group is going to be this last one here. This is going to be example 6. A minus 3 over a squared plus 2a. A squared minus 2a. Notice I just factored it real quick. A squared minus 2a. The reason I factored it is it makes it a whole lot clearer what the common denominator is going to be. And the other one is a squared minus 4. Difference of squares, isn't it? A plus 2, a minus 2. Okay, instead of copying it and then factoring it, I factored it right off the get-go. You don't have to do that. So the factors present are a minus 2, and a plus 2. And since those are all present, they all have to be included in the common denominator. Just like when you have a variable. The squared was present, even though that's x to the first and that's x to the second. The x to the second is part of the factor, so that both have to be there. So the greatest common factor is going to be a minus 2, a plus 2. I know, it seems like a lot of work. A minus 2, a plus 2. You can't make any of this disappear. You have to use it in the denominator. In order to convert a minus 2 to a minus 2, a plus 2, what must I multiply both of these pieces by? Yes, ma'am. Both of these pieces are going to get multiplied by a plus 2. Okay? So in doing that, it creates in the numerator a plus 2 times a minus 3. And interestingly enough, you could see that if you wanted to reduce this, not that you're going to because you need it, but But you would be able to reduce it. But you're not going to, obviously. You're using that denominator. The other one already has all those pieces present. A minus 2, a plus 2. So the a minus 4 just stays as it is. We're going to go ahead and finish this one up, and then I'll let you guys get started. Oh, let's see. Is it coming back to life? Hallelujah. Okay. So, technical glitches. A plus 2, a minus 3 over this. And in order to change this to this, you had to multiply both pieces by a, which gives you that. Okay? So, the denominator is a minus 2, a plus 2. All right? And the numerator is a plus 2, a minus 3, minus a minus 4. I know this seems like a lot of craziness right now, but it'll come together here in a minute. If you don't start multiplying stuff out, this mess is going to be pretty difficult to deal with. If you look at what they have right now, it doesn't quite match what I have. You have to multiply this out, and you have to multiply this out, then collect and combine any like terms you see. Okay, they don't show that step. A times a is a squared. Outside is negative 3a, inside is positive 2a, so that's a negative a. Last is 3 and 2, so it's a negative 6. Okay, now you see kind of where I'm matching what they're doing. And the other piece, negative a times a minus 4 becomes a negative a squared plus 4a. Okay, they didn't show you this step here. But this here, the combination of these two items, is how we got here. So the a squareds cancel each other out, right? Positive and a negative. The 4a and the negative a, darn it, I had hoped I would fit all this on one page, becomes a 3a. And the negative 6, so I just combined that with that. And the negative 6 just hangs by itself. That's the numerator. Which, if I factor the 3 out, is 3a minus 2 over all of this. a minus 2, a plus 2. Boy, oh boy, I'm moving all over the place. You guys see anything that can cancel here? A minus 2's. So your end result is 3 over a plus 2. Takes a lot of paper. The a minus 2's cancel. 3 over a times a plus 2 is your end result. The 3 does not cancel with the a. The 3 does not cancel with the a plus 2. So you cannot change anything. That is it. All right.